In FCAM2012R2 we now have the ability to instigate turn milling. Turn milling basically allows us to use live tooling and combine that with the rotation of the spindle. So we're effectively turning the stock but also moving a milling tool through the material. Now we get a number of benefits when we use the turn milling. And this example is aimed to highlight that. So the first area we can see here, we've got a series of flat faces and holes, so we're going to have some interrupted cutting as it tries to turn the majority of the material. As well as that, the material we're trying to cut in this particular instance, if I go to the stock and look at the properties, you can see we're using a stainless steel, a 302 stainless steel. So this material is known for when we are turning, the swarf will gather around the turning tool and it doesn't break particularly easily. So if we use a milling type tool or a live tool, we can use the chip breaking to actually snap off smaller chips rather than ending up with long swarf from a turning tool. So this seems to be the best way to attack the part. So let's look at what we would do if we were conventionally turning. So here I've got the pattern of faces and then the whole operation. So if I go to my results tab, I'm just going to turn a breakpoint on the rough pass. Note it does say that there is an undercut on this particular feature, and if I go up to these features here, it also says the tool diameter that we've chosen, which is a 32mm solid carbide tool. In this case, just looking at the curve, it detects a small radius in the curve, but we're not going to be too concerned with that. So let's insert a breakpoint at this drilling operation, play the 3D simulation. So in comes my first tool. You can see the end mill that we're going to use to machine away. Let's just drop the speed down. So we're going to machine away those faces, working our way around the part. And then we get our whole drilling operations. I'm just going to move on to the next operation. So in comes my turning tool, into position. We're using a stock curve to trim the shape of the turning operation, and we can work our way down the part like so. So if I continue to play the simulation, we can see there is where the interrupted cuts are. As it turns this area, then there's nothing to cut here, and then back into this region. You can also see we've got a boring operation on the front as well. If I turn that on, this has a pre-drill operation followed by a boring operation on the front face. And again, playing the simulation. Again, just going to increase the speed slightly. So we'll work our way around, drill all the holes, play the next operation, play that turning operation, then we come over pre-drill, and then we use the boring tool to bore out the material, like so. So what we're going to use instead is turn milling. Now to instigate the turn milling, it's quite straightforward. In this case I'm just going to turn off these two operations. These turn milling operations are already done for you. If we look at a conventional turning operation, into the strategy page you'll notice turning is selected, but you'll see there is a new radio button that appears below called turn milling. So in this case, if I go to this example, into the strategy, you'll notice turn milling is selected, and we get a change in the icon that's being used. We can also change the orientation of the tool, you can see here, with the X and Z axes. In this case we've selected a 50mm end mill, and there's also a number of tabs have appeared, so you can see we've got both a turning feeds and speeds tab and a milling speed tab. We've also got under the turning options, you can see we can set a number of parameters. Now in this case you can see we've got some extra parameters, so for example centerline overcut. If I preview the toolpath, the tool comes into position. In this case we're using this turn curve, and I can see if I look from the top we can see we've got the overcut, so the tool starts off center, works its way across the part, and then moves back across like so. So this gives us our turn milling shape. As I work my way down the part, as it reaches the undercut, it will approach slightly differently. So we get down to that level, and now it comes in and works its way back up the material, like so. So we get a more unique shape of toolpath as we're controlling the shape based on this tool we've chosen. So if I go into my 3D simulation, I'm going to play again the first operations. Let's just work our way through. Into the drilling. Now the tool comes along, you can see the milling tool that we've selected. We can now see the motion, so the simulation shows the rotation of the stock as we move that turn mill tool across our part. So now we can see on the interrupted cut, tool then works its way down the material . We can then go ahead and turn mill the front. So let's have a look at that on the machine. In this case we're using a large machine, this is a WFL. Go into my simulation. To the break point. And then play the turn mill, like so.